Hello and welcome to episode 3 of the tutorial series. In this one, we're going to be looking at a BP-only approach to working with network predicted code in Unreal Engine 5, using all of the character movement components, special little qualities and whatnot, and just ensuring that all of this cool stuff is exposed nicely to Blueprint so you can very easily create new movement modes, new kinds of network gameplay, all that kind of stuff, all in Blueprints. And I'm going to show you the quick little plugin that does all of this cool stuff. So jumping straight across to that. Also remember, you can always skip into different sections at the bottom. I've labeled each section appropriately. But let's have a quick little overview of the plugin and how that sort of translates into what we looked at before in the previous tutorials in the C++ section. We're going to do like just a little bit of a discussion on how it works, and then we're going to go straight into the blueprints and how you can get stuff working. Because I think that's what you're here for, right? Just, give you the beans, Spill the beans. So first of all, if you want to work with the plugin, it's this one here. I'll link it down below in the description. It is SMN2 from Reddy-dev, and it's brilliant. It lets you just add anything you want into the prediction loop. If you remember what we did in the previously, the prediction loop, let's get rid of this thing here, was effectively something called the packed movement system, where effectively you just take any kind of variable you want, make sure it's sent through to the server, all that kind of stuff, and make sure you create two versions. One in the saved move, which is what you use as the client to re-simulate moves if there's been a correction from the server, very important, and also one that actually gets sent across to the server, also very important, so that the server knows what you're doing. And yeah, that's basically it. You can kind of see what the author has done here, where they've created an array of predicted booleans, integers, floats, anything you need, even gameplay tags, rotators, whatever you want, and made sure that both those things are available in both the save move and in the packed network data. And upon sending it through, just does a little bit of reflection magic in C++. If you know what reflection is, it really is some cool magic, and adds that into the prediction loop back here, make sure everything's set up properly. So that's more or less how it works. We've worked through that in the previous tutorials. So you kind of remember our approach to adding a boolean into, for example, sprint, or adding in our little network flags, all that kind of stuff. Exact same idea, exact same setup. If you understand how that works, this should come second nature, this part here. And it's just a very, very smart way of doing it. It's actually just a cool way of exposing things to Blueprint. And further down the list here, you can see how the author has also just sort of exposed all of these core C++ functions to Blueprint using K2 nodes, which is pretty cool. So all the most important stuff is exposed to you, so you can use it in Blueprint whenever you want. We'll look into that now. So if we could jump across now to the Blueprints itself, we're already in it. This is what comes with the plugin setup. So this is the standard Blueprint over here, and you can kind of see immediately all that the author's doing here is saying, add predicted property bool. And they've named it. Unfortunately, this particular section, this particular thing uses straight up strings. That's how reflection and stuff works in this case, because remember, C++ and Blueprint can only sort of talk. I mean, Blueprint knows everything about C++, but C++ knows nothing about Blueprint because of how, C++ works. Everything needs to be initialized and all that kind of stuff in C++ for it to recognize it. So this little, reflection stuff is just really cool. It works quite nicely. But anyway, that's why we use an actual little string here, but it's got to match the name of the property we want the C++ to track. So you can see the sprint var here, and sprint var. So basically it says, track this boolean, and then you can see it's in the add predicted boolean, so that it knows that it's a boolean that it needs to look for. And boom, that little variable is now tracked properly in the entire network backend, which means when we get across the stuff, remember how we set up sprinting in the previous tutorial? Well, same thing goes here, right? We got the get max speed node, remember that? And all the author has done here is just said, well, if you've got the sprint variables true, then obviously, change it to 900. You can also add the value in, but change it to this instead of what it is normally. That's what we did before, right? We had a sprint value and then a normal value, and that's how you set up sprint in, any network game or in any game, really. And if you remember the general flow of things, let's just take a quick step back to how things were. The reason why you want to send a boolean like this, it's a better way to put this is B wants to sprint. In other words, the player is indicating that they intend to sprint, they want to sprint, and then sort of allowing the server and whatever the case is to figure out if that's something they can do. And we call that player intent. So we can go ahead and say player intent, excuse my handwriting, or just input will lead to, they want a certain action to occur, or they want to add acceleration or velocity and all that kind of stuff. So let's say sprinting will add in a new max speed. So obviously you want to go to acceleration, which will lead to the change in velocity, which will then go into our movement modes, which do all of the environmental tracing and interaction, climbing up and down ramps, climbing up and down stairs. We talked this through quite a bit, and that'll then give you the output that you desire. And if anything goes wrong along the way, server corrects, whatever, all that good stuff. if you remember that, that's basically what's going on here. And what we're going to be doing now, what we want to do is, well, what I've done. So basically, that's all the information you need at the moment as to how things work. Everything else kind of comes from our knowledge from the previous tutorial. So obviously, this is nice and easy, right? Just setting up a little sprint variable, boom, boom, done, get the right stuff. But if you track back to the previous stuff in the tutorial, I mentioned a few important places, such as you want to worry about your acceleration, you might want to change your gravity, you might want to change, you know, all this kind of stuff. You want to perform movement, you want to maybe edit the Phys flying system and stuff like that. And it can get pretty confusing and pretty hectic. But I'm going to run through the most important sections and what I exposed to Blueprint and how I set up a little design pattern that I'm hoping sort of improves your workflow and also like allows you to just get like the maximum amount of usability out of this as possible with the least amount of effort, basically. That's what we're here for, right? We want things to be done quickly, we want it to be done efficiently, and we want it to be done easily. Otherwise, we'd be doing things in C++, right? We want things to be nice and easy and accessible in Blueprint. We want people from all sorts of backgrounds to be able to work in this in Blueprint, whether you're from a design background, you don't really care too much about C++, all that kind of stuff. That's what we want to do now. We sort of go further on this, because obviously this little example here is quite nice. It explains more or less how the backend works, but let's go dive into that little design pattern and why you might want to use it in the next little section over here. So before we get started, remember all of this code, the full project, is available on my GitHub, link below. You have access to all of this stuff. You can see what's been done. You can choose bits and pieces you like. You can ignore what I've done. You can do your own thing based on your own knowledge that we discussed previously. This isn't a perfect solution or whatever the case is, but it is a cool little way of getting things done in a very simple sort of manner compared to the C++ version. But before we jump into that, let's also just remember that the C++ implementation is probably the better approach, just in general, because you have more access to things. You can do things probably like a good little engineer could probably do things very quickly in C++. But if you want to keep things in Blueprint, if you maybe, number one, allergic to blueprints, two, you want to empower your designers with visual scripting accessibility, or maybe you're a small team that has a very BP sort of focused project, or you just want to like prototype things really quickly in a multiplayer environment, get things out there done, this is great. I mean, I'm willing to say you can probably ship a multiplayer title with this. Maybe not like the most AAA thing in the world, but you can get multiplayer stuff working quite nicely here, even just like for a prototype, a visual, the vertical slice, all that kind of stuff. So yeah, but I mean, that's up to you. You can decide. You can also ask a few other people what they think of this solution, all that kind of good stuff. So let's get started. So just to reiterate on what the prototype does here, sorry, what this plugin does, in the example here, you can see you want to create your particular network replicated variable. In this case, it's the sprint variable. And now we want to add that into the network prediction loop. Obviously, then we go on begin play. All we say is add predicted property, and then we add that in. And boom, that's now done. And now you can use that effectively on the server and the client. That's all you have to do. You don't have to worry about writing any C++ code for that. You don't have to worry about updating your packed movement, all that kind of stuff that we did in the previous tutorial, which is actually quite nice and convenient, right? And like I said, then all of a sudden, boom, you've got this and it works perfectly out the box. Fully networked, all okay, can work at 500 ping, 1000 ping, can work with a bit of packet loss, all the stuff. It ticks all the boxes that you need, that you want. That's the C++ typically was the only thing that used to offer that. So now that we've got this available, it's actually great. It opens many doors. So let's close the base plugin, the example, and we're gonna look at the one that I put together here. Oh, and also remember, in our custom character, we just flip-flop booleans. That's all we do. Like here, you can see got something called holding hover, kind of like a Spyro. Actually, let's dive into the project and see what's available to you out the box now, right? And also, let's do a couple of cool things. So here's the server, and here's the client. Let me just make it a little bit bigger. So all I'm going to do is actually go ahead right away and we're going to look for corrections. p.NET show corrections. So now connections are enabled. Corrections, I mean. And we're going to make sure that we have a little bit of ping. So it's for packet lag. Let's add 500 ping off the bat. It might get a little bit of lag initially. Should maybe get a couple of corrections. You'll see some corrections right now if you bump into a box. Remember, the box is not replicated. So therefore, you can see the corrections happening. But now we can sprint. All we can wall run, jump between wall runs, run around. We can hover like Spyro the Dragon. And this is all working now fully in a network environment with with 500 ping, all the good stuff. You can see there's no corrections happening. Wall running. The whole spiel working nicely. Oh, there are going to be a couple of corrections, obviously. Sometimes this is unavoidable, especially at 500 ping. And it could be anything that causes that. But you can also fly. You can go fly up and down. You can go from flying, exit flying. See if I can land on the wall. I couldn't. But you can change between movement modes very easily. And they all have their own settings and whatnot. And boom, you can see that's available to you. And it's all working nicely. Found a ping, corrections on. And that's all available in this example project that I put together. It's on GitHub. You can check it out. But let's have a look at how things work. I put this design pattern together because I felt like it works quite nicely for getting things done very quickly. It sort of backpedals, or rather like, how can I say it? Kind of like, it piggybacks, that's the word. It piggybacks on top of existing systems. Because now remember, right, like the whole thing about, where's my brilliant little diagram here? There we go. Remember our movement modes, they do a lot, right? You got the Phys walking for when you're walking on the ground, moving up and down ramps and whatever the case is. You've got flying, which basically does the same thing as walking, except you're not flying. You can go up and down. It sort of adds the vertical element in, whereas the ground one kind of removes the vertical element. You've got falling when you know, obviously that's basically if you're not flying and you're not grounded, you obviously can enter a falling state, and that has its own network code behind all its own movement code, and all those things are available. And remember that one little thing we looked at back in the tutorial. I don't actually have it available right now, but you can effectively just change the velocity of stuff before it gets sent off into these existing movement modes. And by doing that, you can change their behavior. So effectively, remember right in the beginning, right? We discussed, well, what's the most important variables to adjust? And what I kind of put together was this. So if we assume that, if you want to create a new thing, or we want to create a new movement mode, whatever the case is, we mostly want to change just a couple of variables. And we kind of still want to do the same kind of logic as what the movement modes do, right? So let's have a look at this, right? So I just said, all right, cool. I want a custom max speed. I want a custom max acceleration. We have deceleration. Remember, like acceleration, deceleration, our max speed. We discussed how all this stuff worked in the previous tutorials. We have a custom braking friction. That you can set to 0. Typically, I just left it in there because some people like that backwards compatibility, but usually I leave that at 0. I don't want braking friction. We discussed why in the first tutorial. We have custom gravity scale. Always nice to have. If you want to change your gravity scales, like, for example, our hovering ability is just changing the gravity scale to a lower value so that you fall to the ground slower. That's all there is to that hovering ability, right? And air control, once again, you can change how much air control you have while you're hovering, for example, stuff like that. Our jump force, obviously, if you're adjusting our gravity scale, you want to jump higher. Like they kind of like depend on each other, so be careful of that. Remember, if you change one variable, it can have a cascading effect on your game balance. But beyond that, that's all I added in here. And I said, all right, when I do that, if we change those up and we change those movement profiles, all we want to do is just change our internal variables. And what this means is that we can now take these variables, make them the primary sort of variables that run through all of the existing code, which means they're fully networked. Because remember, all that we are doing to ensure our network gameplay, works in a networking environment, is once again piggybacking off what exists. We're just changing functions that are already called in the backend code, such as getMaxSpeed is called already, right? If we change that behavior, it gets changed on both the server and client. We're not adding anything new into the loop here. If we update other functions that we know run through the networking environment, then boom, those are also networked already, right? So that's all we're doing here. Is that all we're doing is we're just changing our variables. And if you change your variables, you're basically in a new movement mode already. Think of sprinting, right? We changed the max speed. Maybe we changed the acceleration, and therefore you speed up faster. You get to a new maximum speed quicker. And that's a new movement mode in a sense, but not really. It's kind of an extension of the walking movement mode. But if we look at something like flying, obviously you want our own flying speeds, our own flying acceleration, deceleration, all that good stuff. That's its own little thing as well. So all we're doing here is just allowing you to get a lot of versatility out of very little, which is kind of what you want when you're working. Like I said, we want to ensure this whole thing is as simplified as possible. So once again, I just created a little data asset here for our movement profiles, and there's all our variables, right? Our custom max speed, our acceleration, deceleration, all that good stuff. Also added in, obviously in the C++, we don't have the sprint speed. So we have to add those in here because this is now affecting our blueprints. Because remember that stuff is not available in C++. So we've got a custom movement mode here. We're talking about the custom movement modes. And this is why we're going to start discussing how we create our own movement modes, air quotes, that's what I'm doing here, in blueprints. And whether or not they should block normal physics. This right here, this block normal physics, basically what I'm doing here is I'm saying, like, if you want to go crazy in blueprints and you want to create your own physics and do your own tracing and do your own safe move updated, all that kind of stuff that the existing movement modes do, you can go ahead and do that. But what I'm doing is basically allowing you to avoid all of that complication. I mean, if you're going that deep into blueprints, you might as well be doing it in C++. This is as simplified as I could get it and make sure that it all works nicely. It's got a good little design pattern. So as I said, your little movement profiles, and now I'll have a look, right? So you can see the couple here. There's hovering. Oh, that's a movement profile, right? But wait, isn't that like supposed to be a movement mode? And if we have a look at our custom movement modes, enum, I just created a blueprint enum, nothing fancy here. You can see we got none. Well, the first one's always none. We've got sliding, which I did not implement. You can go ahead and implement that if you want to. And that actually sliding is a good example, because remember, right? Sliding, in a sense, is basically just walking, except, you have different acceleration and deceleration. If you are suddenly on a slope, you want to increase your acceleration. If you're going up a slope, you want to decelerate. So that's just tweaking variables before they get sent through to the walking movement mode, right? And if you want to add another stuff, like you can't slide up a stair, well, then you just got to decrease your max step height, right? And then you can still pass all that stuff through to the walking movement mode. You don't have to redo that code. You don't have to redo all that stuff. You don't have to actually change the code up. You can just change a couple of values, change some existing values and change some variables up, and then send it through into those movement functions. Wall sliding? What is wall sliding, right? Like if you hit a wall and you want to slide down slowly, well, that's just, changing gravity scale, right? Same thing with hovering. We're falling. It's the falling movement mode that we're using. All we're doing is changing one little variable and saying, okay, while you're in the hovering movement mode, all you're going to do is just lower your gravity, and maybe you want to increase how much air control you have, and then you can just balance your game around that. And the wall running is, of course, its own thing. All we're using there, wall running, is we're using the flying movement mode because we want to go up and down. We don't want to fall to the ground. We want to remove gravity, and we're just bumping into walls, making sure that we're setting the velocity to say, okay, go along this wall, and then it'll avoid penetration of other things, because that's what the flying movement mode does already, and all that good stuff's happening in the back end. We don't have to worry about that. So how it works is, now let's go ahead and look at the hovering movement mode, right? You can see I've just done some changes here. You can see I've changed it from 4.0 on the custom gravity scale to 0.4, which means we now fall down a lot slower, right? We just sort of fall down nicely. And everything else is still there. We changed, everything else is basically the same as it was in our based sort of figure over here. You can see this is the top level parent. And then you can do stuff here, and then you can see our custom BP movement mode is set to hovering. And we desired movement mode is falling. So you can see we're saying we want to be in the falling movement mode, but we're actually in a custom BP movement mode called hovering, which we've put over here in the enum. And if you were to go ahead and look at something like wall running, right? Same thing. We just set up how fast do we want to wall run. Basically this thing is an endlessly reusable variable. How fast do we want to wall run? How fast do we want to accelerate and decelerate when we're wall running? Those don't matter too much in this case. All the other things don't really matter too much. But most important, we want to be in the flying movement mode while we're doing this, and we want to be in our custom wall running movement mode. Now, what happens on the actual blueprint side? So that's kind of like the general design flow, right? So we do that. And what's nice about having it in the structure, sorry to go on a tangent here, but this is quite cool. Because this is now the parent data asset, right? If we created a child of this, if we actually went and said create child, and we want to set that to walking, right? That means we can change those settings in walking, and then we can have subsets of walking. And if we were to go ahead and say create new data assets of that walking thing, and we have multiple of them, if you want to change all of their parent variable, like sort of balancing, like for example the top level thing, like let's go into this once more. If you want to change everyone's base movement speed to 800, if we were to update this variable now, let's actually just go ahead and do that to 800, compile and save. You'll notice, no, it's decided to open up back there. They've all changed, right? So if we save them all out, look, they've all changed to 800. Isn't that kind of nice? So now you don't have to go individually change each one. Oh, and also if you have a custom thing here, like with normal flying, you can see our fly speed 1000. If your data asset, your child data asset has changed that, it won't change. So your balancing remains consistent. So that only the variables that have not changed in these data assets will be updated. Isn't that great? So therefore you can maintain everything you want. So if you want walking to work, walk at a certain speed, and then subsets, like let's say you want sliding to be the same speed of walking and all that kind of stuff, and you have multiple versions of different movement modes on top of that, if you change the parent data asset, it propagates to all the others so long as that you have not updated them, which is super nice functionality, right? So that's pretty cool. So it's just a nice data organization thing. Oh, I think Unreal just crashed. We'll be right back. Okay, we are back up and running again. Thanks for that, Unreal. So now we can go ahead and check out how these things work. Let's go back to, I think, so let's rather just look at an example of this, right? So now let's say you created this hovering movement mode, right? Like all you would do there, like I said, is you just go and say new, add new, let's just say like, I don't know, let's call this something. And then you go and create a something data asset that's built off of the thing. So we can actually just go ahead and duplicate this, for example, and call that movement profile DA something. So all you have to do is just say this, duplicate, then change up the variables and the name and whatnot. But let's go ahead and play the game again right quickly. Because Unreal crashed, I might have to redo. Yeah, I'll have to redo some of the settings. So once again, we can actually push up now and just say we want to enable corrections and we want to enable lag. Alrighty. So now we're at 500 ping, playing on the client, and you can see the delay on the server side over here. All good to go. All working nicely, a wall running, all that kind of stuff. And of course, if we get a little bit of height and we hover, well, we don't have too much, air control, for example, right? Like, I struggle to move around. It's kind of like maintaining my velocity in a certain direction more than I wanted to, right? All I have to do to balance that out now, like, or a designer, whatever the case is, can just come in and be like, okay, when we're hovering, like, yeah, with speed's okay. Maybe actually not. Let's increase. When I'm hovering, I actually want to go faster. Let's go crazy. Let's go. I want to go 1,200 units speed. I want to accelerate, that's fine. And custom gravity, I actually want to fall even slower. I want to halve my current descent. But custom air control, we already have 1.0, right? Which means, hold on, it felt a little sluggish. That means we can probably play around with our acceleration value, but let's just up that to like 5,000 and just see how that feels, right? This is, like I said, this is balancing. You can do your little thing. But this just kind of shows you how easy it is to go back and forward and balance certain movement modes. And also, because they're data assets now, you can just have them like available. They can be in source control. You can go back and forth. You can have new versions that you can just put in and out. But let's have a look. Oh yeah, you can see we got like, oh, that was just a little bit of a, that's one of the little bugs that's in the system and you can try and figure out. Oh, you can see I also have a little correction because I bumped into these things, and if I bump into these things, it always has a little correction. But you can kind of see we're now a lot faster. We descend a lot slower. We're a lot faster. So you can see how our balancing is now coming in. Obviously, you can play around with these settings, do your thing, change up how fast wall running works, and you can see you can go from one movement mode to the next, and it all kind of works together. Ooh, that was a big correction. But if you go back and review that footage there with the correction, you can kind of see you did end up more or less in the same space. Even though we had a pretty big, significant correction back, a few moves back, we still ended up more or less in the same place on the client side. Even though it looked like a little bit of a jerk and this, that, you could see all the red boxes. But if you see where you ended up versus where we were before the correction, you can see they more or less match up. All it did was just correct a little bit. And that's kind of what the server does. That's its job, right? And the save moves, you can see those are working because that all seemed to work nicely. We ended up in more or less the same spot. That's what save moves do. It's just, it alleviates the pressure of a correction or the jank of the correction, more or less. So you end up, you get the little rubber band, but it still fixes that whole thing up, right? So you can see how that's all working nicely in the back end there. So you can go around now and just change up how your normal flying works, your normal falling, your wall running, this and that. You can change all the settings up to change the speed, the jump velocity, all that kind of stuff. And what's nice is that because these things are all consistent, like everything maybe has a jump. Maybe you want to jump out of your sliding movement mode, right? Like you want to get like a super boost, a super jump. You can actually have that there as like an actual baseline jump force, and then you can like maybe add in an extra jump force multiplier based on how much you slid. And you can, like I said, this is the world's your oyster here. You can change these data assets up. You can add new variables in. You can add whatever you need to into the network prediction. Speaking of which, let's actually have a look at how that works here. So now we're going to get into the bit of the nitty-gritty here with how the design pattern works and how you can implement it. So setting our movement profiles. Our movement profiles are basically our movement modes, but because we can be just changing variables up, I mean, we can't always call them a new movement mode. There might just be a subset of our existing movement mode, which is kind of nice to have there. And so you can see we set it up by saying, okay, when we start up, just use our normal walking movement profile. That's our baseline one. And you can see all I've done is add in our player intent variables. This is just some anti-cheat so that we can just add in, like, we don't want the player or the client saying, okay, deliberate, I want you to move to this location and allow me to teleport and dash as much as I want to. You kind of want to check them on that, right? So you always indicate intent. You want to dash, you want to sprint, you want to fly in this case, you want to, or they're currently holding hover, which means they want to hover, effectively, right? And all I did was just create those variables here. You can see wants to sprint, wants to fly, wants to hover, or holding hover, and just added those into the network prediction loop here on begin player. Like in the baseline plugin, you can see the example there as well, same thing. So doing the exact same thing. That's all we did. All we did to get the networking working is just add in 3 predicted variables, which is why this blueprinting is quite nice, because adding those into the C++ can just take unnecessary time and timings and all kind of stuff, even though it's nice to do whatever, but like it's quick and easy here, right? And we're just caching our custom character and stuff like that. All good. Alrighty. So where's it now? So let's think about it, right? So what we're doing is, like I said, we're getting the player intent, we're indicating we want new things, we're changing the variables up. Just the pure process of changing our variables, now that's great. That already means that, like, you know, everything's replicated already. If we change variables, they're automatically replicated, which is quite nice because those are part of the backend already. We haven't even added in new variables in that case. But, you know, how do we actually activate these things? So if we actually just follow the trail here, let's say B wants to sprint, obviously on the player, so I'm dashing around between things here. If we are holding left shift, for example, they should try to sprint, right? And if they're not, obviously, so just flip-flopping a boolean. 90% of this is just flip-flopping a boolean, right? Depending on different things. Maybe you want certain inputs to trigger certain things at certain times. Like here you can see, as long as we are like, if we are triggering this ability in the enhanced movement, where the case is in the crouch, that means if we are currently flying, we want to add in a downwards input. You can maybe even change this up to work exclusively in the character movement component, up to you. But this is just how the inputs are typically handled on the player side. And you can see I've done like extra little instructions and things here based on what's currently going on. Am I flying? Am I not flying? Do certain things. I'm currently holding hover. I'm not currently holding hover. That's all it is. Like I said, you're just flip-flopping booleans for the most part. Yeah, right? And then adding in our movement input based on other things, like whether we're moving forward, backwards, up, down. You know how it kind of works for our different movement modes. So let's go ahead now and investigate our B wants to sprint. Let's say, okay, let's find our references, right? Where were we saying, oh, we got set wants to sprint. So we just see that's basically what's exposed to our player. They want to set whether or not they want to sprint, right? But now, where else does it get called? Oh, max sprint. So in this case here, right, we would probably want to have another little function that says, can I sprint? You know? Am I allowed to sprint? That kind of stuff. You kind of want to check the player, like, okay, am I stunned? Am I this? And that's where that would be called, is like, can I sprint? And then you would have an is sprinting boolean, which will then be used to sort of replicate between, you know, similarity proxies and all that kind of stuff, so that you can have the animation playing for sprinting if they have to move faster, if you, depending on how you set it up. Usually you just have that set up as the movement speed. But you can see here that I sort of just set up the bare bones. Like I said, this example project, it's the world's your oyster. You can take this, you can not use this, you can look at this for inspiration or not, or what other kind of stuff. So basically, you can build on this or not, up to you entirely. This is just like a weird little design pattern to help you out. So you can see in this case, all we're saying is that if they want to sprint, we're basically just allowing them to sprint without checking for extra stuff, which is bad in a sense, but this is just an example, right? But if they want to sprint, then we can change between the sprint modes. And all we do here is we've gone to the, where is it now? It's all on the SMN2, all of the main things. You can see here, to get max speed, that's the same function that we overrided in the C++ in the previous tutorials, remember? That's all you need to do to change the speed, is just override that function. Same thing with our max acceleration. All we have to do there is change that up as well. We just edit that function as well. We just change the acceleration there. Our max braking deceleration, oh yeah, all we do is we just, once again, override that in the blueprint and set it up, and you can change how all the stuff works. We can even scale our input acceleration, which is important if you want to change acceleration when there's no input or if there is input, and all that kind of stuff, because this little function here is actually what gets called before sending acceleration between the server and the client, so it's good to override this little function. That's actually something I added in to my little code over here, if you have a look. I did add in a few more variables. So basically I exposed start new physics, because obviously start new physics is important because that's what calls our different movement modes. So that's exposed for you to override. I exposed do jump, because obviously when you want to jump, you maybe want to change the functionality of what the jump does. And in my case, I wanted to change the functionality when I'm wall running. I want to jump at a certain different angle away from the wall. So I needed to implement that. And I follow the same approach as SMN2. Not too difficult to do if you want to change up, if you want to do a little bit of C++ just to, you know, add things in and expose more stuff to blueprints, it's pretty simple. You can just follow what's going on over here. And then here's our little movement profile, stuff like that. But yeah, you can see it's very simple. And then here's our scaling of the input acceleration, which I said is like important, for example, if you want to have acceleration while the player is not holding down any buttons, if you're not actively applying an input vector, which is consumed by the system. If you remember how all that kind of stuff worked. Basically, how that system works is that if there's no input vector, there's no acceleration, therefore we decelerate, which might not be desirable. For example, if you're sliding, you want to obviously slide down a hill without having to hold any movement direction and just keep sliding. So therefore, you would change that up over here. So that's just one little place you can change your acceleration. So as long as you followed the previous tutorials, stuff like that, you probably know more or less where things are. But if you haven't, don't worry, don't freak out. Like, we're going to go through the important parts. All you can do is just follow the code here, and you'll probably understand how everything works. Most important part here, once again, is just the starting physics. What are we doing? So basically, before we pass things across to the physics, the starting physics, the movement modes, like I mentioned, all we want to do is add in our own velocity, change things up based on what movement mode we're currently in, our custom blueprint movement modes, right? So that's why we have this weird thing here where like there's a perform logic before physics functions, and then a perform logic after. Just a little injection of code here, right? So, and once again, if it wants to cancel out from going to the next physics part, it's there for you. But like I said, if you're doing that kind of stuff, if you're doing that kind of complicated stuff, better just to do C++. So what's going on here, right? You can see here that depending on what our active custom profile is saved each time we set it, because if we go to here, we can see we save our current blueprint profile, set it up, send it through to that C++ we have, and then all of our blueprint functions get set up here as well. Because remember, the interplay between C++ and blueprints is a bit odd, but it's there. So you can just keep adding your own variables into the blueprint here and change them up. But now that we know what our active custom profile is, it's basically our active movement mode, right? But it includes both our typical movement mode and our custom blueprint movement mode. Remember that. If we go back to it, remember we have our desired movement mode. What movement mode are we passing our information to? That's the desired movement mode. And we have our custom movement mode, for example, hovering. Yeah. So if we set it up and we change things out, that's what happens here. So now that means before, let's start new physics, sorry. So if we go back to this, we can see that when we're in an active profile, let's say now we have a little switch here on our custom modes. If we are wall sliding, obviously we want to do our little checks, make sure we can still wall slide, do this kind of stuff. But if we can't, we're going to say set custom movement profile. We're going to change it back to, in this case, if we're not wall sliding, obviously we want to fall, right? If we're not able to wall slide anymore, we're just going to go back to falling. But if you touch the ground, it's going to go ahead and just change the movement to the ground movement mode, right? Same thing with hovering. All we're doing is we're checking to see, are we still able to hover? Are they still hovering? All this kind of stuff. And while we're hovering, maybe we want to check for the wall running as well. All that good stuff. You can change up how this logic flows. This is just the basic setup. And if we're wall running, obviously same thing. If we're still allowed to wall run, then we'll do things. Otherwise, we'll go back to the falling movement mode. Basically, this is how you'd set up your normal physics functions, right? Your normal movement modes. But it's very, very simple. It's always like can I enter this movement mode? And can I stay in this movement mode? And if not, change to a different movement mode that makes sense. So if we're not able to wall run anymore, we're going to fall. If we're not able to hover anymore, we're going to either fall, and if we find that we're next to a wall, we want to swap to a wall movement mode anyway, right? And over here, just below this, we have a little section that says if we're in a normal movement mode, right? In this case, let's say we're walking and we're using the normal walking movement mode, right? Or we're using the normal falling, all that good stuff. We want to also just do some logic here too, right? Like if we're not in a custom movement mode, kind of like this would override this usually. But now if we're not in a custom movement mode, obviously then we're just in a normal movement mode. But we still want to check. Like if we're falling, we want to check to see, oh, am I near a wall that I can wall run? Am I near a wall that I can wall slide down? If I'm falling and I'm holding hover, obviously I should swap to the hovering movement mode. So you can see here, if I can hover, boom, and then this is just like a thing with a couple of instructions, like, oh, if my velocity is a certain direction, whatever, and I'm holding, sure, allow them to hover, and then you can change your movement mode. So we're still doing the same thing as we did in the C++, right, where we're just changing movement modes willy-nilly, change between them all the time, going from one to the other. Same thing applies here. So we're following the design pattern put forward in the character movement component, but just in an entirely blueprint manner. And I think it's relatively easy. Once you look through the code and you can sort of see what's going on, hopefully it simplifies it for you. And now this is also where you'd set up your Phys functions. Remember, Phys functions are what we call the things like that. You get Phys walking Those are just the movement modes doing their thing, right? So if we look at a more complicated function, like I said, with the hovering and stuff, all you're doing is updating the variable. You're just changing gravity scale, which means you're still using the falling movement mode with a new gravity scale. That's all it is. We called it a movement mode, but all we do is change one variable. You know? So that's what's nice about this, that you can add a new movement mode in and just like change a variable, call it a day. Then just make sure you can maintain that movement mode state and then swap between them. But in the case of our wall running, right? If we detect that there's an available wall, if we go, you can do it. This code's not too complicated. It's kind of simplified. You might want to change how this works. I just threw this together, but it just compares different walls that it's hit to see which ones it wants to run across. And if you're going from one wall to another object, can you change from that object to another object? All that kind of stuff. Just logic around that. But the long story short is, if you can wall run, obviously we want to either go into the wall run if you're not in wall running and stuff like that. But in this case, we are currently actively in wall running, right? Which means we want to be running our Phys function. So there's our Phys wall running. What do we do in Phys wall running? Let's go ahead and it's just a couple of checks to make sure the player is still valid, all this kind of stuff. The current wall is still valid. But from there, you're just like, oh, okay, do some math. Then we just get into the math, right? Games are just 90% math. We're going to do a little cross product of the vector of the target normal of the wall, multiply it by our up vector, do this, do that. Go ahead and do a little dot product, check to see which direction of the wall we should be going. Are we going in the direction of the cross product, or are we going a different direction based on our incoming velocity? This stuff here is purely gameplay programming. This is what you'd be setting up your own logic. If you want to change which direction the player goes in based on like a different thing, like let's say a wall has a certain direction and the player can only go in that direction, obviously you'd put that logic here. But in this case, depending on what velocity you had coming in, that's the direction your wall run in upon landing. Effectively is what's going on over here. And then it does the little thing where like, oh, if I've changed to a different wall, swap my current direction, this, that. So very simple. And then right at the end, you can see the sequence node. All we're doing is just saying, okay, in this case, we now have a wall run direction, which way we're going, you know? And also we're applying a wall grip strength. Sorry, I got a little confused here. So basically, we're applying a little bit of velocity into the wall so that we grip the wall, right? That's why we call it the wall grip strength. We don't want to like move away from the wall too much. If we get booped away by like a little bump on the wall or something like that, there's a little geometry collision issue. This is just to remedy that, which is quite nice. But all we're doing is just taking our wall one direction and we're timesing it by our current max speed. You can see I'm using the get max speed, which will say, okay, I'm currently using my custom max speed that I've set up. That's why you want to call this function here. And then once that's all happy and done, all we're doing is we're setting the velocity. That's all we're doing. We're not doing a safe move updated. We're not doing all the fancy crazy stuff that's available in the C++ versions. We're not doing like we're not worrying about sub-ticking, all this kind of stuff that you typically think about in the C++. All we're doing is we're saying, okay, here's my new movement mode. This is how I enter the movement mode. This is when I should exit the movement mode. This is what I want to apply while I'm in that movement mode. So once again, we go back up. You say, okay, while I'm in the wall running movement mode, custom movement mode, I want to just be running this. If I can still wall run my Phys. And then all I'm doing is I'm just changing the velocities. That's what you do. All you do is you're changing, all that you want to do in this blueprint approach over here is change the acceleration and the velocity. And that's basically all you want to do. That's it. And then once you change the velocity, this velocity will get sent through to, remember what we said with the movement modes, where is it now, wall running? We're in the flying movement mode when we're wall running. So all it's doing is sending through that velocity into the backend C++, pretending like it's flying, even though we're wall running, and then it's running all the hard code for you. You don't have to even worry about it or think about it. All you want is the end result, which is here, which is just we want to apply a certain velocity in a certain direction. Now, if you run into an object and you get booped off the wall, boom, that's handled for you, right? If you run into a different wall, we've accounted for that. Obviously, this does not account for everything. If you want certain logic to apply, like if you bump into something on the wall and you want to stop wall running without it fixing itself with the grip strength, that's an active thing you need to think about. It's not going to do everything for you. Like, you're still making a game over here, right? But this just helps you. You don't have to worry about all that crazy backend C++. You can just throw a velocity and acceleration at the system, choose which basic movement mode to use, and call it a day. Because I swear to you, 90% of the movement modes you want to put together will be using one of those movement modes. You will probably be wanting to trace along the ground in a walking form. Even if you're putting together a tank, even if you're building a tank, you're still walking in a sense. You have different acceleration values, and if you can only move towards your current facing direction or this or that, when you want to change how fast you turn around, that's stuff you can add in. But at the end of the day, you're still just pushing all this information through to the walking movement mode, right? All you'll be doing in your custom Phys function, like I said, is just changing your velocity, changing how the tank changes direction, all that kind of stuff. If you want to, as I said, slide, and we talk about the sliding movement mode, we didn't implement that at all. You can see it's not implemented because I didn't feel like implementing it. But that's for you to implement if you want to. And then in that case, all we're doing is we're changing the acceleration values. If we're going down a hill, we're going to accelerate and slide faster. If we're going suddenly hitting an uphill or staircase, we want to decelerate because we're going uphill, right? And that's just stuff you have to add in. So that's where your logic comes in. You just go ahead, follow this kind of instruction over here, add in your own Phys for that particular, your Phys function for that. And that's what you're doing. So we're following the character movement component paradigms. We're just slapping it in Blueprint and calling it a day. And where are we actually, I mean, you're probably wondering, like, where are we actually changing movement modes? You can see it's all mostly done here. You can see, like, if we're falling, do this, do that. And remember, on the backend C++, one important thing to remember here is that our falling, our walking, all that good stuff, that is... actually, let me go ahead and show you where the little hack is. I even call this a little hacky workaround. Because remember, our normal movement mode and our falling movement modes, their logic is that if you're not walking, you're going to enter falling, right? So when that happens, we wanted to interact with our custom movement modes. That's all that happens here. You can see that if we were previously walking and now we're not walking, obviously we want to enter falling with our custom settings because that's not handled by C++. So that's what this part here does. Don't worry too much. You can basically leave this as is. You don't have to worry about it. But if you're wondering where this is, I have left a little description over here. Don't worry too much about this, but that's basically what's going on. Because remember, C++ and Blueprint, they don't know about each other. Rather, C++ knows nothing about Blueprint. So that's why you need to add this little section. It's a little hacky workaround, but we got it done. You know, it's important to have. It's there. It's all sorted. It works nicely. So that's honestly, hopefully I didn't explain too fast or too erratically over here. But that's more or less how it works, right? Like I said, most important places you're going to do stuff is start new physics. And, also, if you look at the start new physics, right? If we go in here and we do perform our logic before our Phys functions, you can see our... I don't know if I actually updated it. I did. So here's our something node, right? And that's our new movement mode that we added in. So you can see, all you have to do to add new movement modes in is just like, okay, I want to... Let's say I want to add in a... what do we call it now? Tank movement mode, let's just call it that. For lack of creativity. And now if you're wall running, you want to instead be like, this isn't the wall running thing, but you want to duplicate this thing and say, okay, we now want to be changing over to our tank custom movement mode. And then it'll run through this code, right? Like once you've moved into, then you'd probably be like, okay, in the walking movement mode, when I don't have any other custom movement modes active, I want to check for a certain condition. Can I become a tank? And if so, enter the tank movement mode. And as soon as we enter tank movement mode, this code will run every frame, right? Before the start new physics. There, all we do is, we just make sure we can maintain our tank form, and then we want to do the same thing as we did here with wall running. We want to have our Phys function, we want to change how our movement works, and add in a few little things, and if we can't maintain tank form, then we change back to normal walking form, or falling form, or whatever the case is, depending on what logic you put together. That's the general flow. That's all you got to do. You just go, okay, new movement mode, new custom movement thing added in, add in a new, you just want to go ahead and say duplicate, whatever the case is, and be like, we want to call this the tank movement mode. And then in here, I want a max speed of 1,600, but we're going to move really slowly, so we're going to move up to speed at 500, but we're going to decelerate like really quickly, so we want to like come to stop really quickly. We're going to keep it as that. We want to, what else? Yeah, we want the tank to be able to jump really high, because maybe it's not a normal tank, it's a mecha tank. You're now in a Gundam. And we want to be on the walking movement mode as a baseline, because we want to push our velocities through to walking, because we're still technically walking. And we want to be in tank movement mode. Technically this doesn't make sense, because what happens if the tank jumps? Then it would be in falling. So you want to have then, you can see you can propagate different movement modes. You want to be in tank falling, or this or that. You can see how the movement modes can propagate on top of each other here. Anyway. So now this is set up, we can be like, okay, we want to move across that movement mode and do that kind of stuff. So then, yeah, from there you can just sort of just go ahead and follow this exact outline. And if with input, right? Like, let's remember, most importantly, the only thing that we're sending through to the server, right? Remember, don't forget this part. If you're wondering why your stuff isn't working, it might be because you've added an input and then not told the server about it. So let's say to activate tank, isn't inherent to the system, right? Because remember, like, all of our stuff with, like, changing between, falling, all that kind of stuff is inherent. What I mean by that, let me get into it, is that, effectively, instead of you declaring that you want to do something, it's sort of like, if I step off a ledge, I'm going to automatically fall, right? That's handled automatically. No need to worry about that. That's already network predicted, because that's built into how the system works. But if you want the player to actually push a button and have something happen, that's when you need to go, okay, I want to be once to enter tank form, whatever the case is. Then as soon as you add in that boolean, remember, add it into our little prediction loop at the back here. So you just add in a little section there, and then boom, it's available. And then you then go ahead and say, okay, if I do want to become a tank, can I become a tank? And then you just follow that same design pattern that's been put forward over and over again with each thing you want to do. If I wants to slide, wants to do this, wants to do that, you just keep adding those little booleans in. And of course, if you have any other variables, you've seen the backend C++ for the plugin. If you have like vectors or gameplay tags that you want to add into your prediction loop, which could be important for like the replaying of moves, all that kind of stuff, you'd also add them in here by saying add predicted property, gameplay tag, whatever the case is. But like, always go back to like, can this be used to cheat? And if so, don't allow them to. This is just more for like your own internal handling, which is why I've only shown this example here with basic prediction variables, basic player intent. They want to sprint, all that kind of stuff. And yeah, and with the tank example, you then just go and say, okay, if I push this button, grab our custom character movement component and set it wants to become tank. Just follow the same format. Everything that's you kind of need is here. And like I said, it's not a perfect solution by any means, but I think it's a pretty cool little way just to like get your movement code working super nicely out the box in an entirely blueprint format. And if you want to use my approach here, you can. Like I said, things on GitHub. If you want to go your own direction, do your own thing, go for it. Like I said, if you're not worried about cheating, you can just send whatever variables you want to the server. You can be like, I want every variable to be predicted, which you shouldn't do. That's terrible. But I want all these different things to be predicted, whatever the case is. Don't go too nuts on what you send through. That'll just ruin your bandwidth. But like that kind of philosophy can work. You can go in your own complete direction. You can ignore everything I just told you if you want to, and you can do your own thing based on the knowledge from the previous tutorials. Like I said, the world's your oyster here. You can set up things how you want to set them up. You can create your own movement modes, like the normal C++ kind of way, in blueprints by changing up some of the code as well. But like I said, if you're doing something that complex, you might as well just be doing it in C++ at that point. So this is the simplified blueprint approach that I hope works for you, and I hope that you've got some use out of this, and I hope that I've sort of expanded upon the plugin enough that you can get you thinking about how you want to implement in your game, right? Sure. So I've just spoken for a very long time without taking much of a breath. I hope everything came through clearly enough. But I wanted this tutorial to get done so that you can see how things work, so that you can start working on your project, because it has been too long since the last episode before this one came out. So hopefully that explains everything. If you have any more questions, obviously just send me a message on YouTube or on Twitter or whatever the case is. I'm available most places there. Obviously I can't build your project for you, but if you have any simple questions about this kind of stuff, go for it. If you have any questions about the plugin, you can ask me, or you can ask the dev himself, the author, Reddy-dev. All the stuff for him will be linked below as well, his channel, all that kind of stuff, and the plugin as well. And yeah, from here, you can just do whatever. Hopefully, if you just go through this code and you follow along with what I said, and you have some knowledge from the previous tutorials, you can build anything, right? This is all you need. And whew, that's basically the end of it. All I'm doing right now is rambling on. So yeah, that's it. Aha. One quick thing I wanted to touch on before we actually end this tutorial is that Epic Games are working on a new version of all of this. All the stuff that we've been doing, all the hair pulling, might finally be coming to an end with a vastly improved movement component. I'm going to link this down below as well. You can get I don't know if the image is coming through very clearly in the video. Basically, they're adding a generic movement component, which will do a bunch of stuff. It's going to support all actor types, not just characters. So the circular dependency between the character and the character movement component will go away. It's not going to just be called the movement component. It allows game developers to focus on movement without worrying about the complexities and networking, which we just went through, But it's important to remember all this stuff anyway. It's good to have this, because we don't know when this is coming. So everything I just taught you now on this plugin could hopefully help you to get things done in the meanwhile. Very good to have. And also, like we just did, we're going to empower non-engineers to craft their own movement through modularity and this and that, which is what this plugin attempted to do as well, right? So we're basically doing the same kind of stuff, but hopefully this new movement component comes in, and it comes in relatively quickly. And when it does, don't worry, I intend to make an updated tutorial for you so that you can use this new one instead. Oh, and most importantly, it's got a generalized rollback networking, which is going to be great. And it's going to possibly work with the existing physics system. Remember, we talked about how physics, like game physics, doesn't necessarily work with the network component physics. They're different things because of how complex physics is and the rollbacks and this and that. Anyway, so it seems like Epic's doing a lot of stuff right now that's going to be sort of like marrying all these concepts together, and that's so exciting. The kinds of games that can be made when all that stuff comes together is nuts. The interactivity between stuff, it's going to be very cool. But like I said, at the moment, the best thing we have is the character move component, and hopefully this blueprint approach and the previous tutorials gave you enough that you needed to that gave you enough that you can take it away, do your own thing, get what you need to get done, and yeah. Let me know if you liked the tutorial. Let me know if you liked the plugin and the setup, all that kind of stuff. I'm looking forward to your comments and your thoughts. So yeah, and of course, good luck with your development journey. Good luck with your game. I'm sure there's going to be some exciting stuff happening in the future. If you're working on a game, send it to me. I'm definitely keen to see it. Definitely keen to comment on it. It'll probably just be positive, to be honest with you, because like making games is hard. So, but like if you can get things working in multiplayer now, and if this plugin helped, obviously give Reddy-dev some love on his side. Tell him that you love this component and this plugin so much. And if you like this design pattern that I threw together here based on the knowledge we have about the character move component, let me know as well. I also like compliments. So yeah, that's about it. So have a good day and good luck with your stuff.